Alrighty, people, we are going to be looking at chapter 4 today, starting off with some exponents and more specifically looking at square roots and cube roots. And this is the point in the course where I think if you do not yet know or have not made any attempt to know all the perfect squares and perfect cubes up to a certain point, now's the time to start. So, for example, I would make sure you could answer all or know all of the perfect squares up to 20 squared and all the perfect cubes up to 10 cubed. Okay, and that would make your life way easier. Don't forget that there is a non-calculator section for the provincial exam, and some of those questions are going to involve perfect squares and perfect cubes. So if you haven't yet figured them all out, it might be a good idea for you to go through and write down all the ones that you do know and then fill in the blanks for all the ones you don't. It might be a good idea. Maybe we'll have like a little pretend quiz tomorrow. That's a pretend quiz, not a real quiz. Okay? And see how you do tomorrow. And then maybe we'll try have another one before the end of the week and see how you do. Anyways, that's basic stuff. And so just some more basic stuff if you don't already know. Perfect squares and perfect cubes are just numbers that have an integral square root or cube root. In other words, some integer multiplied by itself either 2 or 3 times gives you a particular number. For example, 64 is a perfect square because the square root is 8. 8 times 8 is 64. Okay, now actually 64 is also a perfect cube. Okay, it's equal to 4 times 4 times 4, which is 4 cubed. As a matter of fact, 64 is a very versatile number in that it has lots of different ways that you can split it up. Let's sort of continue this factor tree here just to get to prime factors. Let's start with the one on the left here, the 8 times 8. I'll split each of those into 2 times 4s. And then we'll take the both of those 4s and make them into 2 times 2s. And so we see that 64 can be expressed lots of different ways. Here is 8 times 8, because 8 also is a perfect cube. So 2 times 2 times 2 is 8, times 2 times 2 times 2, which is also 8. But I don't have to do it that way. I could also look at these three groupings here. 2 times 2 is 4. This is 4 times 4 times 4, which is 4 cubed. Same thing as right there. And also, I can see it's just 2 times itself 6 times. So we don't really have a word for that, but 2 to the power of 6 would equal 64. So the sixth root of 64 is 2. So lots of different ways that we can express 64. Let's sort of look at what we just finished talking about in a slightly different notation style. That's probably one you're familiar with, the square root of 64. Now, we don't write it, but there is a little index there, the 2, that we never write, just like you don't write 1 as an as an exponent. You don't typically write the 1, or as a coefficient, we don't write the 1. We don't write the 2 for the square root. It's kind of given, okay? So you don't often see that written, but it is there. If I wanted to do the cube root of 64, I would put a 3 there, because I want to know what number multiplies by itself 3 times to get 64, and the answer there obviously is 4. And we just finished seeing as well that the sixth root of 64 is 2, because 2 multiplies by itself 6 times, and that equals 64. So a bunch of different notations. Maybe some of them you're not quite familiar with. That's okay. Okay, so let's start with an example here of 625. What I want you to do is just to pause the video and write out 625 in as many different ways as you can. So there's some examples of how we did it with 64. Okay, a square root, a cube root if possible, a sixth root, or maybe a fourth root, whatever. Okay, see if you can, I would start by doing like a factor tree. In other words, break down 625 into as many prime factors as you can, so they're only just prime numbers, and then work from there. So I'll give you a few seconds, and then we will look at the answer. All right, well, let's start breaking up 625 into prime factors. The most obvious one is going to be here is 5. and I see that if I divide it by 5, I get 125. That 125 can also be divided by 5, which gives you 25, and that 25 can be factored by 5 as well. And so 625 is 5 times 5 times 5 times 5. In other words, I could write this a couple of different ways then if I want to look at what I'm expressing here. If I group those two pairs of 5s together, 5 times 5 is 25. So I could say the square root of 625 is 25 because 25 times 25 is 625. Or if I don't want to look at it like that, I could look at individually and I could say the fourth root of 625 is 5 because 5 multiplied by itself 4 times is 625. Okay? Something like that. Okay, well the only thing we need to look at more is just the basic structure of a power term. So that whole thing we call a power. That little guy there is obviously the exponent. And then here is the big quiz question. What do you call that? What's the x? If x or n is the exponent, the whole thing's a power term, what do you call x? If you said base, you're correct. That's the base, okay? The thing that is being raised to a particular exponent. So 3 to the power of 4 is really saying that I'm taking the base, 3, and raising it to the exponent, 4, which actually means 3 times 3 times 3 times 3, okay? But things get a little tricky though when we start having negative bases. Consider negative 6 squared. Okay, what is the base in this question? If you said negative 6, you are wrong, and I'll show you why. So like I was saying before, we don't typically write the 1 often, but this actually means negative 1 times 6 squared. How do I know that? Well, order of operations dictates that exponents are dealt with before multiplication. Negative 6 means negative 1 times 6. Okay, get your head around that. Okay, so I'm going to do the exponent first, then multiply. If I wanted to raise negative 6 to a particular exponent, though, then I can do that, but I have to communicate that somehow, and I do that using brackets, just like that. Okay, so negative 6 all in brackets squared means negative 6 times negative 6. The original one I did there in blue, the negative 1 times 6 squared, actually means negative 1 times 6 times 6. Okay, so 6 times 6 is 36. This is going to be negative 36. Down below here, though, it's negative 6 times negative 6. Two negatives multiplied together are positive. The answer is positive 36. So even though they look very similar, they have a very different result, and that's up to you to figure out the explanation for on the journal question. So no homework question today, but you did watch the video, so congratulations, and make sure that you do the journal question. It's due Friday, by the way, but get it done now, and that would be better for you and for me and for everybody. Have a great night. We'll see you tomorrow.